In this video, we'll look at linear search. First, we'll explain how linear search works. Then, we'll write an algorithm for a linear search. We'll write a Python code for linear search. Now, the first thing you should notice for the linear search is it can be used on an unordered list. Means if the list you're working on, if it is not ordered, linear search gonna be your obvious choice, right? On the other hand, if the list is already ordered, sorted, then the best option for a search algorithm could be a binary search, because binary search comparing with linear search is more effective, more efficient, right? So, but the list, if it is unordered, you have no other choice but to use a linear search. How it works? Linear search checks each item of the list in turn to see if the item you're looking for, it is there or not. It just start from the beginning and then checking the item. It stops when it either finds the item it's looking for or has checked every item. So step number one, it look at the first item in that unordered list. Then thinking, checking if this is the item it is looking for, it stops. Searching stops and say, okay, we have found it. But if it is not the case, that means we are looking at the next item in the list and then we'll keep repeating it until you find it. Okay, that's basically the linear search is about. We're gonna see one more example here. So you're looking at a unordered list, and how linear search works is go to the step number one, means checking the first element and seeing it is 2. Then it is comparing with the element you're looking for. In that instance, we're looking for number 13. So what we're doing, we're comparing it. The element here is 2 and the element we're looking for 13, is it same or not? It is not, so we're going to the step number 2, means checking the second element, which is 3. Again, we're comparing it. If it is not the same, in that instance it is not, we're going to the next step, all right, which is 7, comparing it. And we'll keep doing it until in a position, like in this case, step number 5, find the element, fifth element in this list is 13, and we are comparing, linear search is comparing and say, okay, you know what, that is the item same exactly as it is I'm looking for. So yes, we found it in fifth position. Now here is the catch. Fifth position means we are counting 1, 2, 3, 4, 5. So it's fifth position, right? Sometimes the questions might be asking you to give the index position, and they might ask you to start counting the index position from 0. Like in Python, in a list, the index is always starts from 0. So in that case, just make sure you read the question carefully and looking for that if they're asking you to count from 0 or 1, right? So here we are in the fifth position, the number you're looking for. Now, please note, in the exam, to get a full marks, you should show every step of this algorithm. Even though it's very, very obvious, still you need to show these full steps to get a full marks. Okay? Now, next thing gonna be is I'm going to write a Python code for this linear search. Whatever information I gave you already, whatever information, we know already how linear search works. Based on that, I'm going to write this code. If you're a GCSE students, you do not need to remember or write your own code in the exam. Okay? You're not expected to know this code by heart and write it. On the other hand, it is expected that when you see one, you understand this, okay, linear search is happening there. Okay? Because there's some questions over the years I've seen, they give you the search algorithm and then asking you some questions based on that search algorithm. Means if you don't know what's happening in that algorithm, what is what is happening in that code, you might not be able to answer that. So again, if you're GCSE students, you do not need to remember this code, but I'm expecting the OCR expecting that you understand that code, and then you understand linear search is happening there. Obviously, if you're A-level students, you have to learn it by heart. You need to understand and write your own code yourself. Okay, so now you're going to write a Python code. Please follow along with that. Okay, so let's write our Python code for the linear search. The beginning, let me create a list. I'm giving it name ARR. It is short for array. You can give it any name you want. And then we're creating a list. I'm going to create an unordered list. Okay, so let's start with this very randomly without any pattern whatsoever. Okay, so it is just a random list we're looking at. And let's say we are going to write the algorithm to check if the item 34 is in there or not. I'm going to create a variable and store the value I'm looking for here. Okay, then let's start our function. So I'm going to write a function for the linear search. The word starts with def, and then I'm going to give the function name. Let's say I'm giving the obvious name linear search. Now this function is taking two parameters. The first parameter gonna be the name of the list, and the second parameter gonna be the search item you're looking for. Two parameter. Okay. Then I am creating a variable n and checking the length of the list. How it is full, I'm going to show you in a second, right? So the n is basically checking how many elements there. Now, of course, linear search going to start from here and end there. So it is checking one by one. We are writing a for loop for that. So for I in range, we're starting from the first index, which is 0, and we're gonna stop here. So what is the index number for the, let's check. So 0, 1, 2, 3, 4, 5, 6, and here the seventh position in the index number, right? If I am writing one more number, it's gonna be 8 position index number. So I'm saying okay, start from 0 but it stops before n value. I hope you understand that how it works, the range, how range function works. But I'm going to explain a little bit why I'm writing 0 to n, because I saw people confused about this. Okay, so let me explain. First of all, let's see what the n value means here. So n means the length. Let us count the length. Remember, we are not counting index here. We're just counting how many elements are there in this list, right? So as human, we just count 1, 2, 3, 4, 5, 6, 7, 8, 9. That means my n means 9, right? So, but when I'm using index number and it starts from 0, I'm expecting it goes from here, which is 0, and then up to what index number? Let's check. So 0, 1, 2, 3, 4, 5, 6, 7, 8. So I'm expecting it should go from 0, 0 to 8. And that is the reason automatically when I'm just write down the nth value, it just stops at 8. Okay, if I'm writing any one more number, let's say 700, so my automatically n becomes now 10, and the last index gonna be 9. Okay, so it helps us automatically start from 0 and complete its turn till to the end, and that's how n is useful. Start from 0, stops before the number. All right, let's just clear it up. I hope you understand that. Now when this I is pointing to the first position, first element, we need to check if that is the case, if that is the element we're looking for. So a simple statement, selection statement, if, and the position, in that position element we're looking for are I is the same of the item you're looking for, right? So in this position, I'm looking for item and comparing is the same item I'm looking for. If it is same, we just simply return the statement saying item is found in, let's say I'm adding the which position, which index number basically I found it, right? But if it is not the case, let's say the item you're looking for, it is something not in my list. That means my linear search is going to check this, all the way, and it didn't find it. What do you need to do? We end up with the for loop, come out from the for loop, and then give us a return information saying not found, right? Again, I draw your attention to this part now. As you can see, this return is outside of the for loop scope, right? Because the idea is first we're going to check each and every element. When we see it's not there, the for loop need stops and then not found information comes out. So here the indentation really matters, right? This is part of the my function, but it is not part of my for loop, not in the for loop scope, right? It is not part of the scope there. That's basically it. Now I'm going to call my function, which is linear search. I need to keep the value here. So value is already declared, so just write the variable name basically. And add, as it is returned, so I need to print it. I need to use the print here. No, it's not showing any information, right? So let's go ahead and first. If I press run code now, I'm looking for a number 600 and we can manually see it is not there. So I'm expecting it's going to do all of the searching and matching. And after that, it says, okay, sorry, it's not found, right? So it should show me not found. Yes, right. Okay. Now let's give something it is there. Let's say 40. 40 is there, right? So I'm expecting it's going to find it and say item is found in I value. Let's see what value it should show me. I means the index number of that position. So 0, 1, 2, 3, 4, 5, 6. So it should show me now items is found in 6. Okay. Yes, exactly as it is. Let me check one more. Let's say -2. So I'm expecting to see items found in 0, 1, 2. Run the code. It says that. One more thing, sometimes when you look at code in the exam paper, sometimes it says return -1. Remember, some people do this way. Is -1 simply means that it is not found, right? So what they do, some simply just write down return -1. Again, when it says -1 means that value is not in the list, right? So for example, if I give 400 and if I run code, it should show me -1. It means code is not there. So when you see something like this, make sure you understand it actually refers to that item is not found. So that's basically it. That is the code. Very, very simple code. Again, if you're GCSE students, you're not expected to remember or would be able to write all of this code. But the expectation is you should understand what's happening here, what kind of search is happening here. Because the questions come like this, they'll ask you questions based on the algorithm. You should be able to understand and answer the questions. But again, if you're A level, of course, the expectation is you should be able to produce this code by yourself. Alright guys, that's all for today. Thank you.